So for the presentation outline, we start off with the introduction of what is theranostic itself, and then further discussing on what would be the principle involved in the theranostic, and what would be the components involved when we're designing the theranostic system. What would be the general procedure when we want to using the theranostic approach? What would be the advantage? And lastly, discussing on the diagnostic technique and also the therapeutic strategies in theranostic. And lastly, we'll be giving you some of the success story from the theranostic approach in clinical application. So the word theranostic itself is actually derived coming from therapeutic and also diagnostic. So which means this approach is combining both diagnostic and also treating cancer through using of the radiotracer in one system. And this approach is actually an option available for metastatic disease that fails to respond well to the established systemic therapy such as the conventional chemotherapy. And this concept was first introduced in 1946 in nuclear medicine with the use of radioiodine pharmaceuticals for thyroid cancer treatment. So just to brief you based on this diagram first. For the diagnosis purpose, we'll be using the gamma radiation because the gamma radiation will be usually be captured by the imaging such as PET and also PET. So the gamma radiation will be used as some of the examples of gamma radiation will be lutetium, technetium, gallium, and also in certain cases in one system it will also be having alpha and beta radiation as well for the therapeutic purpose. And next it will having the linker. The linker will be, the function of the linker basically is to act as the stimuli where it will be when there's a stimuli approach, then only then the radionuclide will be released. Like for example, the alpha and beta radiation just now be released and exert the effects of the therapeutic. And next will be there will be the targeting agent, or in some paper or some journal will be reporting that it as a ligand or carrier molecule. So this carrier molecule will be responsible in making the system to be very specific to the cancer cell, because each cancer cell will be express their own protein. Hence, through the usage through the carrier molecule, where it will be becoming specific to the specific cancer. Right. So as mentioned earlier, the approach will combine diagnostic and therapeutic capabilities in a single platform, and it involves the use of diagnostic radioactive biomarker to image biologic phenomena to express specific disease target, and then use therapeutic agent to deliver radiation for target cancer cell destruction and selectively bind to cancer cell, thus will minimize the damage to the healthy tissue. So just to share with you a conceptual diagram of what is planned for my PhD study. So I'll be using the radionuclide of gamma radiation for the imaging purpose, and there will be a linker to be selected. And as mentioned just now, certain systems will be using the alpha and beta radiation for the therapeutic. But for my study, I'll be using a therapeutic agent, and that therapeutic agent will be encapsulated into a nanoparticulate system. And then there will be a ligand, specific ligand that will be targeted to this specific target protein. So these are just a general procedure on how the theranostic approach will be applied. So the first step will be patient will receive the intravenous injection containing the radiotracer at the PET center. And then after that, it will take approximately around 1 hour for the radiotracer to be absorbed, and thus patient will be required to stay or to lie on the PET table as the machine scan the body for the cancer cell. And the scan result will indicate whether there is a presence of the cancer in the body or not, and if yes, the nuclear medicine physician will report the image and proceed with the decision by the oncologist whether they would like to proceed for the follow-up treatment radiotracer or not. And okay, so to discuss what will be the advantages using the theranostic approach, first is that treatment can be tailored to the individual taking into account the factors such as genetic, lifestyle, and also environment. And as this approach, what the unique approach about this theranostic will be, it integrates both diagnostic and also therapeutic approach, allowing personalized treatment plan based on the specific characteristic of patient cancer. And it uses radio tracer that selectively bind. Is it okay if I didn't use the mic? So it uses a radio tracer that selectively will bind to the cancer cell, thus will minimizing the damaged tissue. And lastly is because of the diagnostic just now, it enables to monitor treatment progress, thus allowing adjustment for the treatment plan if needed. And through this approach as well, usually it will be providing a much clear resolution in terms of the imaging. Right? The attractive point by using the theranostic agent is most journal will reported that it will have fewer side effects. Right? And as for the diagnostic technique in theranostic, as mentioned earlier, the gamma radiation will be responsible to provide the image, and it will be combined with the molecules that have been used in the current treatment, where the molecules such as folate, hyaluronic acid, transferrin aptamers, antibodies, and peptides will be tagged with the gamma radiation. Hence, the imaging provided will be specific and usually we provide a much higher resolution for the imaging. And as mentioned just now, the gamma radiation example will be technetium, iodine, and also gallium. And the radiation such as gamma emits the electromagnetic radiation that can be detected by imaging systems such as SPECT and also PET. And as for therapeutic technique, there are two main forms that if we use the radiation, which the first one will be the alpha and beta radiation. For alpha and beta radiation, they will have their different mechanism on how the approach is to damage the DNA cells on the cancer. So depending on how we would like to approach, then we could decide whether which radiation we would like to choose. So these are some of the example commonly used in clinical nuclear medicine practice. One of the limitations of theranostic is that the radionuclide that we use will not be meant for all type of cancer. So it will be very depending on the cancer. So for example, there are cases where the same radionuclide can be used as the therapeutic agent and also diagnostic agent in the case of the treatment of thyroid cancer and also neuroendocrine tumor, where iodine is being used. But for the prostate cancer, for example, the involvement of radium and also technetium differently being used as the diagnostic agent and also therapeutic agent. And I would just to highlight here that some of the agents have been already approved by the FDA, but some are still in the clinical trial phase. So just to share with you some of the success story from using the theranostic approach in cancer treatment. So in this case, patient was targeted alpha particle therapy with radium-223 and also actinium-225 in the patient of having metastatic prostate cancer. As you can see, the tumor have been spread all over the body. And after 7 cycles of treatment, with 6 weeks apart, it shows demonstrating dramatic response in the metastatic lesion with near resolution of the PSMA uptake and corresponding dramatic reduction in the PSA. And another success story will be the prostate-specific membrane antigen avid metastatic prostate cancer with lutetium-177. Index lesion in lymph node, bone, and liver demonstrated that after cycle 2, the hepatic and nodal metastasis were no longer conspicuous, and after 4 cycles, the spine metastasis was no longer conspicuous. So for conclusion, these various imaging molecular target and radiopharmaceutical with different form of radiation emission have a very high potential to emerge as next generation theranostic. As for Malaysia, it opens up opportunity for us to explore for this technology to be used in the cancer treatment in Malaysia. And as for myself, it will be potential for the development of new drug delivery system for the cancer treatment. And with that, I end my presentation. Thank you, everyone.
Can everybody hear me without a mic? Okay. Now we open up the floor to anybody who has questions for the senior lecturer over here. Any hospitals have used this here in Malaysia?
Based on my limited literature, so far I have not encountered any report yet on terroristic has been used in Malaysia. Not yet. I think no.
And doing this kind of scanning, right, do you need to, like a gamma, you need to have a fixed things, like,
Fixed thing.
like if you're doing a gamma knife treatment, you need to have, for their head, then they will need to have a cover or something like that to stabilize your position. This kind of thing, do we need to wear a suit or something like that?
Right. For in terms of how we conduct the imaging, is going to be the same as the current treatment. It's just that for this one, it is combined in the diagnostic and therapeutic system is being combined into one. So in terms of how it is being done, it is still the same as the usual way.
To put it into a layman understanding, so we will be like a photostat machine going in and just scan through and just do a treatment.
Yes. Yeah.
Wow.
Yeah. Yeah. So based on say when we being the imaging is still require us to be into the machine and it detects, so the biomarker will the imaging will be the same as what currently is. It will show the markers. Yeah.
Any incidents of reaction to the intravenous drug that was administered to the procedure?
Okay. Yeah. So any incident, we mean any side effects? Yeah, side effects of the treatment. Based on my literature, yes, there are few reported because of the when it's specifically targeted to the receptor. I think it's alpha radiation, where because of the after the it being bombarded or it's being the effect comes in, there is a tendency or there's a possibilities for the alpha particle to be moving to the neighboring cell as well. So there is tendency to occur, but it's not going to be as catastrophic. It's a minimal chances to happen. There is a chances of side effects happen. Yeah. Yeah. Is that answering your? No. Yeah. Not that I've read. Not that I've counted. Yeah.
So it hasn't been used at all in this country?
Nothing that has been reported yet in Malaysia. Yes. But I saw a news stating that there is just a collaboration last year happening between ICON and also one of the institutes stating that there will be a clinical trial soon in Malaysia for this technology. Yeah.
Yeah, hi, Baki.
Yeah.
Thanks for the very lovely presentation. I'm not a cancer expert, all right, but I do work in the field of medicine. So my remark might be off the mark, but maybe you can clarify it.
Okay.
So I think firstly, this theranostic approach, to my understanding, is already available in other countries.
Yeah.
For me, there's an abundance of knowledge about what they have seen, what they have performed. So I was wondering how this particular research that you might undertake would be something groundbreaking or something that would contribute to science.
Okay.
So that is one aspect. The second aspect is, if whatever that has been discovered in other countries and they have already shown what unique particle that works and does not work, how would you think that your exploration into this would in some ways contribute to newer areas in science rather than just reinventing the wheel?
Okay. All right. Thank you for your question. To answer the question on in terms of the novelty for my study, because for this project, actually, I'm working with Agency Nuclear Malaysia. So we were in discussing on using a radionuclide, because most of the study that have been, the radionuclide that have been used is gallium, technetium, and lutetium. So we are trying to explore any other radionuclide that can be used to act as an alternative for the current radionuclide that have been used. So we would like to, and then after that, we would like to compare in terms of the effectiveness of the system.
I mean, that's in line with what our other fellow here has actually asked about the adverse effects. Is there a reason to explore a new radionuclide in light of any other side effects that was already available in there?
Okay.
That makes you think that you should supplant that particular particle with yours.
Okay. Not to answer that one. Not that we come to that part yet. Yeah, we are still just trying to figure out whether it's having any difference between the current radionuclide being used. Thank you for your remarks. Yeah.